So Alyssa, here's number 27. It looked like you already had A and B done, and I did double check those and they look good. So I think it was just part C you were a little unsure on. Your first two terms actually look good. It was the next two that needed to be adjusted slightly. So part C asked you to find the first four non-zero terms in the Taylor series at x equals 0 if for a function h such that the derivative is that radical 1 plus x squared, and that h of 0 equals 5. So that tells us basically what C is, right? So what I did there was, instead of trying to we have to integrate there, right, to get back to the original function, and rather than trying to integrate that function, you can just use the Taylor polynomial, because they just want, and really that's what they want you to do, because they want the first four non-zero terms in the Taylor series. So I would say that h then is going to be the integral of that polynomial function, and so then you just integrate there, right? You get the integral of 1 is x, the integral of 1/2 x squared is x to the third over 6, and then the integral, obviously, of 1/8 x to the fourth is minus x to the fifth over 40, and then, of course, the fourth term, or the first term, which, depending on which order you choose to write it in, is your C value, or h of 0, which is 5. So really, I guess the 5 should come first, because that's your first term, and then just going from there. So I hope that clarifies 27C. So Alyssa, here's the question you asked about. I think it was number 6 on one of the AP exams. So part A, you nailed it. Good job. Your polynomial is absolutely correct. I took the liberty of rewriting it in just a slightly different form. My answer is the same as yours. The reason I did that was to help you see how to get the answer to part B, because in B, they just asked you for the coefficient of the 22nd, well, not the 22nd term, that's what you have to be careful of, the coefficient for x to the 22nd. So if we look at how our coefficients are working and how the coefficient compares to the degree, right? Because you wrote the third degree polynomial function, but what you'll notice is that the series alternates, and so we have to be careful about the sign on that term that has x to the 22nd. And so what we have to pay attention to is that every two terms the sign flips, right? But the term also does not agree with the exponent, or the degree of the term itself. So the number of the term, in other words, the 22nd term, would actually have degree, or I should say the degree. If you have x to the 22nd there, then that's actually going to be the 23rd term. So when you start counting by twos to see, whether you're going to end up with a positive or a negative sign there, because that's the only difference. In other words, if I could even just look at the last term right here, I'll circle it, right? This is your fourth term, but it's degree 3. So we want the term that has degree 22. We want the coefficient for that. So if we just look at what you have written there, we can use that. We can say, okay, we know that we're going to have 5 to the 22nd power. It's going to have radical 2. It's going to have x to the 22nd. We won't include that because they only wanted the coefficient. Then on the bottom, we're going to have 2 times, and then it'll be 22 factorial, right? Now, the thing we have to be careful, though, about is what is the sign on that term? Should it be positive or negative? And again, that's where you have to be careful, because it's degree 22, but that means it's actually going to be the 23rd term in the series. And if you just count by twos, flipping the sign back and forth, you'll see that that actually comes out to be a negative there. Alyssa, here's part C of this question. They asked you to use the Lagrange error bound to show that the value of the function at 1/10 minus the value of the polynomial that you wrote at 1/10 would be that absolute value would be less than 1 over 100. So you have to remind yourself of what that's actually the remainder there. When you do the absolute value of the function value at some x minus the polynomial value at that same x, you're really looking at the difference between the two. They also call that the remainder, and the formula is in the book, so I went ahead and copied that there for you. So you can see what that is. And then I just listed my values for X, C, A, and N. Now, the book uses those variables. Other places will use different variables, but X is whatever you're plugging in. C, in this case, because this is Lagrange error bound, is some value between 0, your center in this case, and 1/10, what you're plugging in. And you want the maximum value there because we want to make sure that we're looking at the maximum possible error. And we want to make sure in this case that it's less than 1/100, or that's what they're asking you to show. And so A is your center, which is at 0 in this case, and N is 3. So if we go ahead and plug in our values into the formula, we can see that you're going to have 1/10 to the fourth, and the bottom is going to be 4 factorial because N is 3. So the question is, what do we plug in for F, the fourth derivative value of C? In other words, what do we use for C? Well, in this case, one thing we would want to do is look to see whether the function is increasing or decreasing. And if you look at the fourth derivative, that would be sine. And sine on that interval between 0 and 1/10 is an increasing function. But the thing about it is, if you put one, so that means you should use the upper boundary 1/10. The issue about putting 1/10 in there is then the function is not easy to evaluate. But if you just say, well, what's the maximum value that sine can be? So you don't actually, they said the maximum value between 0 and 1/10, but really just what's the maximum value of sine ever? And that's +1. So what we can do is just say we're going to look at the sine. When sine is 1, that's the maximum value, times that 625, and then that just makes the math real easy. So you have 625 over 4 factorial times 1/10,000. And then you see you have that fraction there. We want to show that that's less than 1/100. I don't know if this was a calculator allowed problem or not, but they do reduce you can reduce that fraction. I used my calculator. It actually reduces all the way down to 1/384, which is definitely less than 1/100. I think you would be okay, but you can ask your teacher about this, whether or not it would be all right to just leave it like this. I think it's pretty obvious right there, even that you've met the condition, but maybe ask HB about that. So this is part C. Let's take a look at D. So Alyssa, here's part D, and they are simply asking you to find a function G that's defined by the integral from 0 to x of f of t dt, and then write the third degree Taylor polynomial for G about x equals 0. So what I did was I just copy pasted our answer from part A, and I only went to x squared, the second degree there, because when we integrate, we're obviously going to end up with a third degree. So I just went ahead and did the integration there. I think it's pretty straightforward. I'm sure you knew how to do that. But that's part D, and that's the whole question. So I hope this helps. I'll be back in the building either tomorrow or Monday. If you want to talk in person, we can certainly do that.